In the previous video, we saw how to build a simple oscillator using the 555 timer that gives us roughly a square wave out. As we mentioned, it's not exactly square. That could be fixed up. But sometimes you want to be able to control the duty cycle of your output rectangular waveform. That's fairly easy to do by adding a single resistor to your circuit, but reconfiguring the oscillator a little bit. In this case, we will actually use that discharge transistor to discharge the capacitor rather than having the output go low and then gradually discharge the capacitor. So here's the circuit as you would probably see it in a circuit diagram. However, once again, you can't really see what's going on in this form, so we're going to look at it with the block diagram of the 555 inserted. Once again, we'll start by assuming that the capacitor voltage is low. It's discharged, which means that the flip-flop sets, which means that it goes high. But now note that in this case, here's the main reason you have that inversion between the flip-flop and the final output. When the flip-flop is high, in other words, when the capacitor voltage is still relatively low, you do not want to be discharging that capacitor through that discharge transistor. Therefore, it has to be off. Therefore, when the output is high, you want the base of that transistor to be low, and thus that inversion. Now, one thing to note here that I actually did not note in the previous video is that the reset pin is connected directly to the positive supply voltage. That guarantees that the reset pin will not be activated since it's a low active reset. So, our capacitor voltage is fairly low, the discharge transistor is off, and so our timing capacitor, C sub t, begins charging through the two resistors, R1 and R2, which are, as you can see, connected to your positive supply. Now, eventually, that capacitor voltage is going to reach, guess what? 2/3 VCC. When that happens, the flip-flop resets. It goes to 0. But now note, since that is inverted, that inversion goes high, it turns on the discharge transistor, and now the capacitor starts discharging through R2. Now note, just through R2, not R1. It charged through the sum of the two. It discharges through only R2. Now this does bring up one potential issue, which is when that discharge transistor turns on, it not only has to handle the current for discharging the capacitor, it also has to handle whatever the current is through R1 from VCC. So if R1 gets too small, the current through that discharge transistor could potentially get a little bit larger than you might want it to be. So with that in mind, you probably want to keep R1 about 1K or larger. But now note what happens here. If R2 is much bigger than R1, let's say that R1 is 1K and R2 is 100K, then the capacitor charges through 101K, it discharges through 100K. Those are almost the same, so the charge and discharge times are almost the same, and you get not quite a 50% duty cycle. It's not quite square, but it's awfully close, and the larger you make R2 relative to R1, the closer you can get, but you can never really reach a 50% duty cycle with this particular circuit. By varying one or the other of those resistors, you can change the duty cycle. If you reduce R2 relative to R1, then it's going to discharge a lot faster, and so your duty cycle is going to get larger. Now note, the problem with that, of course, is if you just made one of those resistors variable, then you not only change the duty cycle, you also change the frequency. So that's a little bit of an issue, potentially at least. Now, as far as the frequency of this circuit goes, this is a little more complicated. Again, we're not going to work out the details here. I'll simply show you what it is. We may derive this in another video at some point in the future. But bottom line, the frequency out of this circuit can be calculated as about 1.44 divided by R1 plus 2R2 times C. So your frequency calculation is a little bit more complicated there, but it's completely straightforward. So we've seen two circuits. First, very simple one, a single resistor, single capacitor, which gives you fairly close to a 50% duty cycle. And we've seen another one where you can fairly easily set the duty cycle that you want by adjusting the ratio of two resistors. In future videos, we may look at a few other oscillator circuits for special purposes. For example, how to more easily control the duty cycle, how to get exactly a 50% duty cycle. But that'll have to wait for the future.